Okay, so we've seen how we can write to an additional listener, in this case the signal R listener. Do a separate session maybe about creating the signal R listener, doing customizations to the enterprise application block. But for now, just realize that it's part of the VNC logging assembly, and you can just use it. And all you need to do is enter it into your configuration file, point it at a formatter, and you get the output streamed real time. So let's go back and look at the code and better understand some of the different things you can do with log and why you might want to use some of the overloads. We're probably not going to cover overloads right now. We're just going to continue to focus on a message and a category. But let's look a little bit more deeply. You'll notice in the constructor of main view model, it says log.constructor. That's interesting. In button 1 execute, it says log.info. In button 2, it says log.debug. In button 3, it's log.trace. And then in methods 1 through 5, it's trace.12345. So why so many different ones? Well, let's go see what some of the overloads are. And you're not going to see everything I'm going to mention now, but I'm going to show you by way of overloads what the original thinking was, and then we'll talk about a new direction VNC logging took, which is to make it more suitable for tracing the activity as a program's running. So think about logging from the standpoint of you may want to log some information, you may want to log errors and exceptions, you may want to log stuff that normally you don't care about during the normal operation and maybe you want to filter out. So if there's an error, you might say log.error, and then the overloads for error include you can pass in an exception, you can pass in a message. We've already kind of seen that. So all the logging overloads allow you to pass in a message. That's a given, with the exception of, log.error allows you to pass in an exception. So we'll cover exceptions. Well, actually, there's an example down here in button 3 execute. Forgot I put this in. So button 3 execute is going to call method 1, and we've seen before that method 1 calls 2, etc., 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 all the way down to the bottom where method 5, which is where we do the division. So if an exception is thrown from method 5, it's going to bubble up, and mercifully we have a try-catch block up in the button handler, so it's not going to crash the application. So if this if this exception is thrown, this is a good example where you might want to use log.error and then pass in the exception. And I'm going to show you two things here which are foreshadowing something we're going to talk about in a later session, but the category is also passed in. So when we cover different category sources, we're actually going to log the message twice, and that allows you to potentially route the log message to a different destination. But for now, just want to see that log error allows you to pass an exception. So while we're here, and now let's just go back up here. So if it's not an error, what maybe is slightly less of a concern, well, you might want to log a warning. Warning has the same overloads as all the other ones. In addition, you can pass an exception to a warning. Then the next level is, or next priority, I'm going to introduce a word here, priority. The next priority might be information, info. Maybe the next priority is debug information, and then the final priority is trace. So when I originally created VNC logging, I was thinking in terms of you're a developer and you have a desire to send a message, to record a message. What should you be thinking about? Well, why do you want to send the message? Is it an exception that was just thrown? That might indicate it gets logged, it gets put in the event log. Is it just kind of a warning? Is it general information? Or is it only stuff that you may want to see under certain circumstances? Debugging and tracing. So now listen carefully. You remember when in the first or second video we saw logger.write, the actual enterprise application block method? The Microsoft overloads allow you to pass in a message, a category, and a priority. What VNC logging does is it puts the priority in your fingertips right as you say log dot. So trace is one priority. Info's another priority. Debug's another priority. So if we go back and look at the SignalR listener, just because it's kind of easy and visual to see this, let's go see if we can see the difference between log info, log debug, log trace, etc. So let's move this out of the way here. So every time we push a button, some logging occurs. So button 1 execute log.info. So let's go find that over here. The word enter, okay, well it says enter in a whole bunch of places, but so we have the date and time in the millisecond, we have the category, and then we have 100. Okay, interesting. Enter and end, so there's enter and end. So maybe info translates to 100. Okay, let's go look at the next one. Button 2 execute. Log.debug. Button 2 execute, enter, end. All right. 1,000 appears there. That's interesting. So maybe debug equals 1,000. Let's go look at button 3. Log.trace. Button 3, enter. Oh, so trace looks like it's 10,000. Then if you look down, method 1, 10,001, method 2, 10,002, method 3, 10,003. So behind the scenes, what happens is the priority, which gets passed in as part of the log entry, which is what the framework logs. VNC logging turns that priority into a method call. So log.debug is equivalent to saying logger.write message category priority 1,000. Log.trace is the same as saying message category priority 10,000. So my thinking was, depending on what the developer's intent was, are you logging an exception? Are you logging some general information, a little bit of this, a little bit of that? Or are you, putting out a lot of detailed tracing information that maybe you want to filter out? We haven't covered filters yet, but we will. The priority can help you filter things out because Microsoft provides a priority filter, and I think we're going to cover that in a couple sections from now. So I started off thinking that error warning, info, debug, and trace, and maybe a whole bunch of different debug and trace levels would be the way to go. And then later on, I started to realize that maybe there was a different way to think about it, and it was less about priorities and filtering things out. And that's when I introduced the notion of a named logging event. So if you go back and look at the constructor, log.constructor is indicating, oh, you're in a constructor, and so I want to know that. So what the log viewer lets you do, and I'm not going to cover this in too much detail, but it gives you some named overloads to log that are color-coded in the viewer, and they're somewhat architecturally significant. So if you're familiar with clean architecture and having the domain and your domain services at the core of your architecture, and then maybe some application services, and then in the outer layers of the onion, your presentation layer, your persistence layer, and then maybe things that are, cross-cutting. So the log viewer provides the ability to color things based on their priority. And instead of making you remember that, oh, log domain is trace some number, I created an overload to log to where you can use the actual name. I'm sure this is not clear, but I think once you use the logging a little bit more and you're, sitting here going log dot, what should I do? You can see all sorts of different named priorities, and they all have the same overloads where you can pass in a message, a category. One final thing to show you that I don't think we've covered yet. All the log methods, regardless of what method it is, can return, they always do return a timestamp. It's a long, so I store it off here in a variable, and then all the overloads can be past the timestamp. And what that automatically does for you is it calculates the time between this call and this call. So if we go back and look at the log viewer, you'll notice that button 1, enter, doesn't have a number between the last two pipe symbols, but that logging method was recorded at 15, 17, 11, 195 milliseconds. The exit call, I'm looking at button 1. The end call, it took 0.017 seconds for this to occur. So you get timing built into the logging framework in addition to, because of the time stamping and the formatter, the time the call occurred. So you can learn a whole lot about how your application is going by looking at the time things are taking and then when in time they occurred. So those are some of the things you can do with the logging overloads. And the nice thing about the log viewer is it makes it easy to see it, and it provides some coloring, highlighting. Of course, though, all this information is available in the log file. If you write it out with the flat file listener or the rolling flat file listener, so you have complete control over where you write output, what the output format looks like, and then the log overloads give you the ability to kind of control things from a priority standpoint, which will probably make a whole lot more sense when we look at priority filters. Last thing to go through, and we've already seen this before. I'm going to scroll down here to the end. Remember that way down at the bottom, method 5 actually does the division. So if we try to divide by 0, it's going to throw exceptions, and exceptions going to bubble up. So but the nice thing about log.error is it automatically will produce the stack trace of the exception. So if you look at it, the log message says attempted to divide by 0. That was the exception message that was thrown. And it shows you at, and you can just kind of see it was in the main view model, and then it was in method 5, which was called by 4, 3, 2, 1, and then it was finally caught up here at the top in button 3 execute. So simply by passing in the exception to log.error, you get a nicely formatted exception stack trace, which hopefully helps you figure out what happened.